Hello everyone. So my name is MIRGESH GUPTA. I am a BTech third year EPH student, and today I made my project on the meteorological data and rainfall prediction using AIM, using ML models on the course project of Fundamentals of AIM. So let's get started. So here we will first see a brief introduction. So rainfall prediction is a vital aspect of meteorology that supports agriculture, water resource management, and disaster mitigation. Now, this project applies machine learning algorithm to analyze the historical meteorological data and establish some patterns that influence the rainfall events. Processing the features such as the temperature, humidity, wind speed, and pressure, how AI and data analytics can enhance the efficiency and reliability of the weather prediction systems. So the project objectives or the outlines of the project is basically first the project definition. So we need to understand that the need for the accurate rainfall prediction using the meteorological data set. Data pre-processing, so it's a very much required in the field. Like having the data set is not enough for applying the models. We need to first pre-process, like finding out the missing values and filling those missing values or removing those missing values or and then removing the outliers in the data, inconsistencies in the data, then normalizing the data, and finally that conversion of that data from categorical data to numerical or maybe the vice versa. Exploratory data analysis. So visualize the relationship between the variables and rainfall using the graphs and the correlation plots like the heat map. Model development. So train various machine learning models using the like the linear regression, random forest classifier, and the XGBoost model. Then the problems that we face is the rainfall prediction is highly complex due to the non-relationship among the weather parameter like the temperature, pressure, density. So as we know, the density of the air varies continuously in the and and as an aspect, also the other parameter pressure, temperature, these also varies continuously in the atmosphere, and as a result of that, the weather changes frequently. So traditional statistical models they often fail to capture these complex dependencies. The inaccurate rainfall forecast can affect the agriculture, water management, and also the disaster preparedness as well. Now, there is a need for the data driven machine learning based approach to improve the prediction accuracy. Now, the project mainly aims to design a robust ML model that could analyze the meteorological data and also it could predict the rainfall effectively. There is the data set overview. So, the data collection is basically I have collected the data from the Kaggle site. It is from the 2010 to 2020, majorly focused on the five to key feature I discussed before also on the temperature, pressure, humidity, on the wind speed, and these are the snippet of the variables that I've used, and this is the target variable finally the rainfall to be predicted by using those features. So this is the brief description about them. So temperature, as we know, that is mainly measured in Celsius. This influences the evaporation and the cloud formation. Humidity, it's basically presence of moisture in the air. Higher the humidity, increases the more chance of the rainfall. Wind speed, so daily average wind velocity in kilometer, like wind velocity changes, right? Increases, decreases. So we have used the average wind velocity affects that affects the moisture transport and also the density of that moisture in particular region and the cloud movement. Pressure, so atmospheric pressure, low pressure often indicate the rainfall condition. There is the rainfall finally, which is the target variable, which is need to be predicted based on the features. This is the data pre-processing. So in the data pre-processing, we will be dealing with the missing value handling. So missing data can affect the model accuracy. Solution is that missing values were handled using the imputation technique, numerical columns, example the temperature, humidity. So these are imputed using the mean or the median values of the respective columns. Like what we do is we take out the mean of that column and fill those missing values with the mean of that column. For the categorical data, we commonly use the mod of that data because they are basically in the categorical format, and at most of the times they are most of the times one or the other value repeats. and they are based on the frequency. That's why we use the mod to impute the values. Visual, so it shows a bar plot or a table of missing values before the features with different scales like the temperature in degree Celsius, wind speed in kilometer. This can bias the model. Like as we know that different physical quantity are different units, and also that so it becomes a problem like temperature should be in degree Celsius and the wind speed in kilometer per hour. So we need to take care that the wind speed in kilometer per hour and not in meter per second, or the temperature in degree Celsius, not in Kelvin or the Fahrenheit um, scales. Uh, because if they are, then it would bias the model, and this will not give a good accuracy. Scaling and normalization. So features were normalized to a range of 0 to 1, or standardized to have zero mean and unit variance using the min-max scaler or the standard scaler from scikit-learn library. A side-by-side comparison of scaled and unscaled data using a bar plot or the uh, pair plot. Encoding. So basically, the categorical variables like the weather conditions, whether it will rain or not, they need to be converted to a numerical format for machine learning model. And I have discussed that we need to use the mod technique to impute the missing values. Then solution categorical variables when encoded using the one hot encoding or the label encoding. Like I have used the one hot encoding, and I will quickly show the reprocessing that happened. So firstly, I found out the isnal values in the columns, and based on that, firstly I have dropped the rainfall, that is the target variable, and dropped the NA values of this column. And after that, I basically use the fill NA method to basically fill the columns missing values with the mean of that column. And this is the thing. And for the remaining categorical data is being filled with the mod of the column. And after that, we are converting the date, because the date is something like although in numbers, but it is not in a way that we can process this. So firstly, we have to convert that date. So I have converted the date by spreading into three columns: year, month, and the day. Uh, and this is the conversion of the categorical data to the numerical data for the processing and for evaluating the model. And as you can see, final result was this, that the everything that the wind direction, that was direction was converted into the numerical format, and also the uh, target variable were also converted to the numerical data form. And this is the conversions of the normalization of the data. So I have used the standard scalar format to convert to basically scale the training and test data set into standard scale of 0 to 1. So moving ahead, yeah. So this is the data analysis. So this is basically the heat map of my data set. And as you can see, this is the gradient of the color. So as more darker the red is, it is nearly one. So it basically shows the correlation between the variables, at how much the variables are being related to each other in the data set. So as you can see that this linear line, this is the more in the darker side. So it means they are much of the related to each other, uh, like more or likely zero point 0.9 to 1 region. So it shows that they are very much likely to related with each other. And this is the basically the box plot. So it's basically for finding out the outliers in the data. And this is the IOR range, as you know that I, uh, the maximum range is IOR plus the Q3 value, and the minimum is the minimum Q1 value minus the 1.5 of the IOR range, and the values lying are classified as the outlier. So you can see as they are bulk around in the region. Some of the values are being bulked, and the rest are not being in the data. So ML models that I will be using. First is the logistic regression. So this is a simple model that assumes a linear relationship between the features and the target variable. There comes the random forest, the ensemble technique model that builds multiple decision trees and then average out the result to improve the accuracy, and then reduces and use for reducing the overfitting of the data. XGBoost, this is the extreme gradient boosting. So it's a powerful and scalable model that is based on gradient boosting, and it uses the decision trees as the base level. Like the random forest average out the result of the decision tree, but what it does, it uses the output of the decision tree, and based on that, it works out on the output of those decision tree, and and then predicts for the next decision tree. So it's work on a gradient system, and in the each step it try to minimize the error. And as a result, it is known for its high efficiency and ability to handle for the large data set without overfitting. Cross validation and metrics chosen. So the cross validation is a technique to assess the performance of model. It helps to ensure that the model is not overfitting, and also it generalizes well to the unseen data as the test data set, and it mentioned how many folds you have to use in the cross validation. Like this is the snippet of the my cross validation. So yeah, so in this you can see the cross validation that I've cross fold validation that I use is for about 5 values. Now the best model details that we got is for the XGBoost model. And why the XGBoost? So the accuracy performed better than any other model like the decision trees or the random forest and any other linear regression in terms of the root mean square error, mean absolute error, or the R square error scores. So low root mean square error. So it produces the lowest among all the models, indicating the best predicting accuracy. Feature importance. So XGBoost allows us to identify the most important features contributing to rainfall prediction, improving the model interpretability. And this is the snippet of the classification report of the XGBoost, and this was the accuracy what we got for the highest. And also among the other feature, other thing like the precision recall was also very much good among all the other models. This is a brief of the models that I've used. So this is for the logistic regression, and you can see the model model accuracy. What we got is for around 84%, and this is for the random forest. So random forest what we got is around 85%. But as you can see, the XGBoost what we got is a 85.5. So this was basically the change in the data set. And when we use a cross validation score, it compared the data, and it was there that the XGBoost perform much better than the other models. And this is basically the classification report of the random forest and the logistic regression as well. Regression curve. So the precision recall curve is typically used for the classification problem, like the predicting binary outcomes, and measure the trade-off between the precision, the percentage of relevant results retrieved, and the recall, that is a percentage of relevant results that were retrieved earlier. However, since projects involve rainfall predictions or regression problem, so the precision recall curve may not be directly applicable. Instead, for regression problems, evaluation root means better, they are more appropriate. So this is basically the precision recall curve, and you can see this is a more pretty much fits the data, and it is a more of the leading to a straight line, and in the end it's slightly tilted because of some of the outliers that were mismatched in the data because of the large data set. And this is basically the precision recall was classification report of the on the random forest. So this was the some inconsistencies in the random forest classifier. So that's the reason we use XGBoost model over the random forest. Confusion matrix. So again, this is based on the logistic regression. So the confusion matrix is basically a type of representation that is used for the predicted and the actual values. So you can see the X label shows the predicted and the Y label shows the true values of the data set. So when it predicted that the tomorrow it will not rain, so uh, and the true values that it will not rain tomorrow were predicted correct around 20,687 times. So basically, these diagonal entry show when the model and predicted correctly. And basically, these diagonal entries show then what the model predicted and what was the actual were different. So these were the time they were different. Basically, this was the confusion matrix was built for the logistic regression. Now this is error analysis. So predicted versus the actual plot, regression plot. So the plot helps visually assess how well the predicted values match the actual values. Any discrepancy will be shown as a deviation from the straight line, which is the y is equals to x passing through the origin. So the deviation will be um, shown in respect to the y is equals to x9. So as you can see, this is the like this is the predicted and this was a residual. The residual is basically the predicted minus the actual values. So there is a deep difference. Like this was the from passing exactly through the origin, but there is some outlier data set also remains in this data. Finally, the conclusion. The best model we got is the XGBoost. XGBoost performed the best among all the model tested, providing the lowest root mean square error and the highest accuracy among all, and also it strong predictive performance for rainfall prediction. Model accuracy, the model's performance was validated over the five-fold cross validation, ensuring the ability to generalize well to unseen data. And the unseen data is later on used for the test data set. Key features. So the temperature, humidity, pressure, these were identified the top three features that influencing the rainfall prediction as determined by the feature importance for the XGBoost model. Improved forecasting. So the model showed promising results in accurately predicting the rainfall, which can significantly aid in weather forecasting, agriculture planning, and disaster preparedness. Future work that are being done and that should need to be done. The model can be improved with additional data like the regional climate factors and more advanced technique like deep learning for higher accuracy and the robustness. Like we can use the LSTM models and how much of the neural networks to process that data. So future scopes and the limitations. So the more data, so more diverse data set and longer time frame would enhance the model accuracy. Higher resolution data. So using hourly data instead of daily would improve prediction precision, especially for the short term forecast. So like having hourly data increases the more monitoring of the changing pattern of the weather, like as compared to the daily coverage. Ensemble and deep learning. So ensemble method or deep learning model like the LSTMs could capture complex patterns and would improve the predictions as well. Additional features, adding the meteorological features like the wind direction or the cloud. This could increase the model accuracy for heavy rainfall predictions. Deployment ideas. So deploy the model for real-time forecasting with automated alert for weather-dependent industries like the agriculture, where the weather is a major criteria of their dependencies. The limitation that we face is the data quality issues and the generalization to unseen regions are the current limitation, but that could be improved with more diverse data or the data availability of the remote regions or the far reach regions that would improve the accuracies of the model and thus the predictions. Works in the progress globally that is being done. So next gen climate model, the major meteorological organization are they are working on the integrated machine learning into the global climate models, basically to improve the long term rainfall forecast by simulating the effects of the climate change. Like the climate change is basically developed over a lot of years, but as a recent pattern that is there, the climate is being changing over many regions rapidly. So and as we know that weather changes much more frequently than climate, but still there is some correlation between the climate and the weather, and that can be used to to have a good prediction on the weather forecasting and rainfall prediction as well. So yeah, that's all from my side on this project. Thank you, and yeah, thank you so much.